Add or subtract these fractions. Well, as indicated, this is an addition problem, but strangely enough, it doesn't look like we can add them together. One's a fraction and one's not. Well, when you're wanting to add fractions, you need one common LCM, one denominator that works for all the different fractions in the problem. So it's easy enough to make 4 into a fraction by putting 1 in the denominator. The second denominator has a plus sign, so we'd like to try and factor that. But if you recall, we cannot factor the sum of squares. We can only factor the difference. The signs have to be different, so you could add and subtract to make the middle go away. You can try and factor this as much as you'd like, but you'll never make just x squared plus 9 because you'll always have a middle term, either a negative 6x or a positive 6x. So let's look for our commons. Well, there's nothing common, so I'm just going to write down this x squared plus 9 as my denominator. I'm not going to write the 1 because anything and everything multiplied by 1 doesn't change. Now I need the leftovers. And as I said, that 1 is leftover, but it really doesn't change anything. So let's go back and make both fractions contain the same denominator. This first fraction is all done. There's no fixing necessary. But the second fraction in the denominator, we're missing that x squared plus 9. So we do it to the denominator as well as to the numerator. When there's no equal sign in the problem, you must do both to the numerator and the denominator multiplied by the same amount. Using the distributive property, I get 4x squared plus 36 plus x. So are we done? Well, let's write that in a better order. 4x squared plus x plus 36 over x squared plus 9. So in order to know that we're completely done with this problem, we have to make sure that the fraction doesn't reduce. 36 breaks down. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't go, 6 and 6. Those are all of our choices for the last term. Our first term we have a couple of choices, 1 and 4, 2 and 2, and of course we need an x in each of those. But if you notice, this last sign is a plus, which means that they're going to have to be the same. So how can you do any of this multiplication and add it together and only end up with 1? It's impossible. So this doesn't reduce. So this is our final answer.